Hi, and thanks for hitting the snooze button. I'm Neil Headley. So I was prepared to write off a literal lifelong battle with insomnia to just being a part of doing more than 30 years of morning television and radio. Well, when I dug a little deeper, it turned out there was far more to learn. So in this series, we try to help people fix their sleep by figuring out why mine is so horribly broken, and maybe we stumble upon some answers together. You're about to meet my new friend, Dr. Aric Prather, sleep scientist at UCSF, studying the causes and consequences of insufficient sleep and carrying out interventions to improve sleep among people with insomnia. As our history keeps getting written by the stupid virus, I found a study that Aric was part of a few years back that put an interesting twist on research into sleep and our resistance to a much more common and less insidious virus, the common cold. And Dr. Michael Grandner is back from the University of Arizona as well. He's talking about the latest science from the sleep world, too. But let's get you started here with Dr. Aric Prather. Aric, everybody that's on the show, whether they are, the lead guitarist for a rock band or a world-class neuroscientist, everybody gets the same first question, and it is this. How did you sleep last night?
Oh, gosh, I have two little kids, and so I feel like I haven't had a great night's sleep in the 8 years in which I've had kids. And so I'm down here. I'm down here in Southern California. I live up in San Francisco, but I'm down here in Southern California with my in-laws. And so it's a new, different bed, different room. They do get to watch the kids a little bit more in the morning, so I do get to sleep in a little bit more than usual. But, without fail, my 4-year-old son, Jackson, wakes us up at around 4 a.m. And that has been the case for the entirety of his life. And so last night was no different. I'm a little bit used to it, but, that's a little snapshot of my life and my sleeping.
So as a scientist who studies sleep for a living, are you tempted to try and shift his sleep, or at 4 years old, is he too young for that?
He's not too young for it. Certainly. So I do study sleep, and I do treat patients with sleep disorders, but adults. And, as much as I'd like to think it, kids are not little adults. And so the sleep system is a little bit different. The behavioral techniques are different. And so I try to separate my work and my family life in that domain. We certainly, did a better job with our older son who sleeps through the night, no problem. But our younger one, I think it's, part of kind of sleeping in the same room as his brother and all that kind of stuff. And not having the same kind of structure that our older son had just because of out of necessity. And so, I'm tempted, but I would defer to my pediatric sleep colleagues for that assistance.
Yeah, I can tell you right now that Linnell Schneeberg over at Connecticut Children's Medical Center is listening to this right now. And she's going, okay, memo to self, write Aric an email. But how do you navigate knowing that you're going to wake up at 4 o'clock in the morning more often than not? What do you do to compensate for that, either on the back end or how do you deal with that so that you're able to function cognitively?
Well, it can be challenging on some days, and other days it's not so bad. Certainly, I'm by nature a little bit of an early riser, so it's not I'm up around 6 anyway, and so it's not too bad. I don't have a hard time getting back to sleep. I think it's just the disturbance. But as we know, our sleep drive diminishes across the night. We have lighter sleep in the morning, and so a lot of people are waking up earlier, and that's part of life. I guess it's I try to make sure that I get to bed at a decent hour. I'm certainly not someone who burns the midnight oil at all, and so I still get my I'm a sufficient amount of sleep, despite intermittent interruptions by young little ones.
I'm fascinated by, and this is something that I keep talking to various researchers about, is the difference between research in the sleep world versus research in pretty much every other area of science, especially nutrition, where there will be a study that comes out this week that says X food is bad for you. And then there'll be a study, 18 hours later that says, hey, that study that said it's bad for you, it's garbage because here's why it's great for you. And then there'll be another study that comes out a couple of days later that says, no, both studies are wrong. Here's what the truth is. Where with sleep, it seems to be moving forward on a pretty balanced, steady trajectory. And one of the things that I loved is that Michael Grandner alerted me to a study that you had done. And some of the data in this study goes back, 10 or 15 years now. But it is still just as valid as it was the day that it came out. And you could make the argument that while the world is in the middle of a global pandemic, your study with some data that is 10 or 15 years old is quite possibly more relevant now than it ever was. I'm talking in particular about the study that you did talking about your susceptibility to a cold and the link to how much sleep you get. Can you hit the treetops on that for people who don't know about this study yet?
Yeah, no, absolutely. I mean, so, broadly, we believe that sleep is kind of intimately related to our immune system, right? And that's been kind of well documented in animals and humans, and we're still trying to uncover some of the specifics about that. But, typically people, when we study this, we study, some very specific aspects of the immune system, say, how is sleep related to T cell functioning or B cell functioning? But, the immune system is, incredibly orchestrated, right? It's a symphony, not just, and so, really trying to understand kind of clinical outcomes that require all aspects of the immune system to work together to protect us is really important, and really kind of hits home some of the meaning of this sleep disease risk kind of connection. And so, in most cases, though, like diseases develop over a long period of time. And so there aren't that many instances where we can actually look at and control exposures. But that was what we did here. So we were really interested in sleep and susceptibility to infectious illness. And there aren't many ways to study that safely in humans, with the exception of working with my friend and colleague, Sheldon Cohen, at Carnegie Mellon University, where he's kind of over his career done a series of viral challenge studies, cold studies. Pittsburgh cold studies is what they're called. And so in this instance, we were interested in sleep and whether someone would get a cold if they were exposed to a known quantity of rhinovirus. And so what we did was we measured people's sleep using wrist actigraphy. So, a souped up Fitbit to give us estimates of how much sleep people were getting and how fragmented their sleep was. And we did that over a week's time. Then they came into the laboratory and we squirted live rhinovirus into their nose. And then to track their symptoms and whether they developed a cold, they were quarantined in a hotel down there in the city of Pittsburgh and tracked over around it depends on the study, but like 5 to 6 day period where we culture their nasal fluids to see if the virus is replicating, and then we do a couple of tasks to get an estimate of true symptoms versus just kind of asking people if they're feeling sick. And so those two things are, the first was we would have a lowly research assistant collect tissues throughout the day, and then they'd put them in a plastic bag, and then they'd weigh the bag and subtract out the weight of an empty bag and the tissue, and you get an actual estimate of a nasal secretion, mucus secretion throughout the day.
I think that's how you identify whether or not you are a lowly lab assistant, is if you're the one that collects the tissues for something like this, you're the lowly lab assisant, right? You're like the red shirt on Star Trek.
That's right. That's right. And then we measured whether people had the degree to which they had nasal congestion. And so we would have people, every single day before they got the virus and after, just so that we could control for size of kind of nostril size and things like that, we would have them put their head back and we would put a dye into their nose and time how long that dye got to the back of their throat. It turns out this dye has like a taste to it. And so people could, we could see it, but they could also tell us, when it got to the back of their throat. And the longer it took, the more congested they were. And so if people were infected, meaning that the virus was replicating, and they had symptoms that met a certain threshold, they were deemed to have a biologically verified cold. And so the study ends up becoming just, yes, no, you have a cold or you don't. And what we found was, lo and behold, and consistent with everything that we think about the importance of sleep and protecting us from infectious disease, is that people who slept less on average were significantly more likely to develop a cold. And this is after adjusting for a whole host of, potential confounders that we also know put people at risk. And then when we kind of binned out the amount of sleep that people were getting, just to get an estimate of how strong this effect was, it turned out that people who slept 6 or fewer hours per night were about 4 times more likely to develop a cold than people who slept more than 7 hours. And so, it seemed like, this is consistent with lots of other studies, but is the first kind of experimental model to support sleep being a critical and independent risk factor for developing a cold following an infection.
And that's a pretty heavy number. I mean, and just to make sure that everybody got that and it didn't go by too fast, more than 4 times more likely to catch cold, and the only variable factored into that 4.2 times was how much sleep you were getting. And I keep finding these nuggets, whether it's things like colds or whether it's various cognitive functions or things like that I try to hold up for people and say, look, here are the numbers. And this is one of those that just kind of whacks you in the face. Now, I guess the logical question from where we are today versus where we were when this study first came out, can we extrapolate anything that you found with this study and come to any conclusions about COVID from it?
I think so. I mean, there's a couple of things that I think are interesting about that. I do think that, sleep does play a role in this relationship, and there's no reason to think that it wouldn't be the case for the SARS-CoV-2 virus. I think one thing that is important to point out in using this data from this study is that, of course, we squirted rhinovirus into people's noses, and what's fascinating is amount of sleep was not a significant predictor of who ended up getting infected. Right. It always blows my mind that we took people and we put the virus in their nose, and there was still a portion of people that just don't get infected, and we don't really know why. There are some factors that we think across those studies that make a difference. Things like smoking status seems to if smokers are more likely to get infected, and that probably has relations to kind of wear and tear on the system and things like that. But so it was really predicting who ended up developing symptoms bad enough to be deemed having a cold. And so I think what it does speak to is, obviously the best predictor of infections of COVID-19 is exposure to the virus and, lack of social distancing, lack of face mask wearing, those types of things. But, it may play a role in among people who become infected. Does it end up leading to a more severe disease, severity that, maybe requires intervention that other people don't need, right? That maintain being asymptomatic or very mild symptoms. And so I think that might be where sleep is, puts people in some level of risk or protection. And one thing that we can't tell from the study is which I think is relevant to COVID-19 is the role of sleep in recovery from these infections, and certainly the study that we did doesn't speak to that, because it wasn't something that we continued collecting once people were in the the hotel, though it's, obviously something that I very much regret not doing at this point, but that wasn't the goal of the study.
Yeah, and I mean, you can't really do or maybe you can, and I just haven't heard about it yet. You can't. It becomes difficult to do a study like this with something more serious than the common cold, because if you ask for a bunch of volunteers and they're going to volunteer to get a cold, that's one thing. But to voluntarily get people to expose themselves to COVID-19, with the exception of that group that's making all kinds of headlines this week in Alabama, all these kids in Alabama that they're exposing themselves to the virus, and whoever gets it gets some kind of cash payout, which is terrifying to me. But there's ethical, obviously, considerations to voluntarily giving people something as serious as COVID-19. Yeah.
Absolutely.
Yeah.
I think that the one place where, this sleep immune story is particularly relevant to COVID-19 is in what we know about sleep and vaccinations. And like this, sleep and susceptibility to infections and the common cold in this case, there's pretty strong evidence, in my view, that sleep and potentially circadian factors are related to vaccination responses as well.
Oh, see, this is okay. See, here's the new wrinkle. Tell me more about that, because sleep and vaccination responses hadn't even crossed the radar for me. What's the skinny on that?
Yes, I mean, there's been, probably, six or so studies, separate cohorts that have, looked at whether kind of sleep measured out in the world by self-report or by wrist actigraphy, or sleep deprivation in the laboratory predicts antibody responses to vaccines, various vaccines, from the influenza vaccine to hepatitis A to hepatitis B. We've done some of this work both in influenza and in hepatitis B. The first study was in midlife adults, 40 to 60 years old, where, at one point in time, you could find people that were naive to the hepatitis B vaccine. It turns out now, when kids are born, most of them end up getting the hepatitis B vaccine really early in life. But, that wasn't always the case. And so we were able to recruit people who had never been exposed to this novel virus in the form of the vaccine. And so, we measured their sleep using wrist actigraphy over 7 days, and then they went through the hepatitis B vaccination series. And in that case, we found that, people who slept less, just like with the cold study, were, generated fewer antigen-specific antibodies to the vaccine. And in fact, though we don't ever expose people to hepatitis B to see if they're really truly protected because, of course, of ethical concerns and things like that, the CDC does have guidelines for how many antibodies, you need to generate to be considered, clinically protected. And when we followed up with these participants 6 months after the final vaccination series, we found that people that slept, again, kind of 6 or fewer hours, were, nearly 12 times more likely to be left unprotected than people who, slept more. And so, again, it's a case that, people that don't get enough sleep might be those at risk, or at least those that aren't going to be what we think of as protected out in the world if they were to come into contact with hepatitis B. More recently, in a study published just a couple months ago, we looked at the influenza vaccine. And in that study, we were, particularly interested in wondering kind of when does sleep matter in the vaccination journey for promoting antibody to that vaccine. And so in this case, we measured sleep over 13 days, and this was just by self-report diaries. But we measured it, and then the vaccine fell like, a couple, 4 day in the fourth day or the third or fourth day of the diary session. And so we were able to look at the days prior to getting the vaccine and the days following. And in our data, it looked like, people who slept fewer hours on the 2 days prior to the vaccine were the ones that had fewer antibodies later on. So that's those nights seem to be more strongly related to kind of how many antibodies they produce to the influenza vaccine. And of course, this has to be, replicated and all these kind of things. But it does speak to whether there's a role for understanding and assessing sleep as part of vaccination policy, right? So if we know that people are really short sleepers, maybe they're ones that need, additional titers measured to see if they need boosters to vaccines, or, if it turns out that there's a particular time, like say it's the night after you get a vaccine, that's really important. Telling people when they get their vaccine, that their vaccination, that they, try their best to kind of get a good night's sleep, or if it's the night before, kind of sending an alert to someone like, hey, we know that sleep is important for vaccines, try to get a good night's sleep before you come in. I think importantly, in no way am I suggesting that if people are poor sleepers, they shouldn't get vaccines, because that, regardless of how people sleep, vaccines are incredibly powerful preventative tools, and, should be taken very seriously. But that's, I think that's an important policy consideration for this research, which oftentimes we don't have as clearly.
I assume it must be frustrating for clinicians, especially, who sit there and go, there is so much that would be improved. For example, you talk about vaccinations, things like that, that if only people would pay more attention to their sleep. But I hear from so many people that, and it even comes in the conversations about COVID and everything else, where people are talking about masks and all these things. And when I talk to people about, there is a visible boost to your immune system, a trackable boost that you can get from making sure that you're getting an appropriate amount of sleep, people feel like, well, yeah, I can do that, but I'm going to throw a mask on because I feel like a mask is a bigger, and I'm sure that from a soup to nuts perspective on it, yes, if you're going to pick one over the other, I would probably opt for the mask over making sure that I've gone from 6.5 hours of sleep to 7.5 hours. Sure. But there seems to be this pushback from people with all of the things that are impacted by sleep, that by virtue of just going to sleep, you're not really actively doing anything. There's an act involved in putting on a face mask. We're going to sleep, you're not really doing anything, so people feel like that's not really a step they need to take because that'll just happen when it happens. Do you know what I mean?
Yeah, I mean, I'd like to think, so one, I think if you had to choose, definitely wear a mask over an extra hour of sleep. I think any epidemiologist would support that.
Yeah.
I do think that I'd like to think that the dialogue around sleep has improved over time. I've felt very fortunate to be doing this work at a time where it's more part of the conversation, and I think some of it is a function of the research, but I think also a function of like improvements in technology for tracking people's interest in kind of optimizing their health and consumer products kind of capturing the imagination of many people across the country and the world. And so, sleep is something that, people are looking to kind of hack and gives us an opportunity to, provide some kind of science-based techniques for improving people's sleep. But I do hear you. It is not as active as people think it's not as active, right? We obviously are on the same page with it's incredibly active, and it is something that is part of our DNA and our kind of our human experience that has been conserved across millennia because of how important it is for survival and for kind of thriving as a species. I think one way in which I've dealt with this, clinically and with the public is really talking about all the active things that people can do to optimize their sleep based on all the sleep science. And, this is obviously particularly true for my patients who have insomnia, but, people that are just poor sleepers in general, like things that people can do to take an active role in improving their sleep. Though, I will say that one of the things that I try to impart to people who are worried about their sleep is, sleep is something that people never even wonder how it works until it stops working. And then they, become really obsessed with making it happen. But, sleep is not something that we make happen. Sleep is something that comes to us, that kind of washes over us. And so a lot of that trying to make happen often ends up being barriers to something that is so natural.
Yeah, I've heard someone say before that the moment you're trying to sleep, you're defeating the purpose right out of the gate.
Yep. So, yeah,
I got to admit to a certain amount of good-natured stalking when it comes to you, because before Michael Grandner mentioned your name to me about this study, I watched you were already on my radar for a long time as someone I wanted to talk to because of the video that you did for Wired, where you talk, and I feel like that video's got to be almost a year old now, where you were talking to people at 5 different stages of life, and you were talking to them about sleep. Everyone from a 10-year-old up to a graduate student and then a sleep expert, this variety of people. And it was interesting as a fan of that video, listening to the things that people learned about sleep from talking to you. But I always wondered, what did you learn about people's perceptions of sleep from everything that was involved in doing that video? What did you take away from that process?
Yeah. So, thank you for bringing that up. I think we made that back in November of last year. And it was a great opportunity because I was actually a fan of the 5 level series before they had even, asked me to do it. And, the thing that is it's such a challenging marathon to make that because we did it all in one day. And, there was a lot more footage that didn't make, that was on the cutting room floor. But the biggest challenge was that you didn't know, the people that were coming didn't know what the topic was. And so there was no way to prep for their responses. And so I'm not someone that has rewatched it. So because I don't like watching or hearing myself. But I remember that laid out, right. It was a 8-year-old kid and then a teenager and then a college student and then a graduate student and then another sleep researcher. And so it was I believe it was the teenager who took this crazy long 6-hour nap every day.
Yes.
And I was concerned for his health because I was like, this sounds so, he was really serious. And it made me think about kind of how, people try to navigate the world and fit sleep in whichever way that they can. For him, I remember that it was he would get up early to go to school, and then he would try to do it later in the day or something like that. And it was such a strange thing, and it gave me pause to think about kind of the variety of the people that are out in the world and are trying to navigate the sleep landscape. But then also it made me think about probably how poorly we capture that variety in research. Right? When I think about the studies that we run, we're running a laboratory study right now trying to understand the relationship between sleep and racial discrimination and cardiovascular risk. And, we do a very thorough screening of people's sleep, and they have to show us that they get a sufficient amount of sleep before they come into the lab, that it's, that the schedule is stable, or they're out, because we want to understand our experimental mechanism and how that affects sleep. But that cuts out a lot of the population, and that's troubling for me when we try to then take kind of the findings, whether it be about the immune system or mental health or cognition, and try to push those inferences onto a larger population. And so I think that was definitely kind of a broad thing that I took away from that experience. Also that, people knew a lot about sleep. I mean, like the college student, I almost felt like she could be doing the wired thing. I mean, she knew all the terms, and I mean, again, she didn't know what the topic was about, and it was really fascinating. It was really fun, exhausting, but I've gotten a lot of good feedback. I get emails now and then from people that'll watch it, often like in the early morning hours, which they think is so funny. Because they can't sleep. And then, also from those emails, I've gotten a lot of kind of really off the wall questions that people are really trying to seek answers to. And as a clinician, I think there's a lot of people out there that could really benefit from more researchers and clinicians getting invested in sleep, because it's a universal experience, but it can certainly go off the rails in a myriad of ways.
What, you just gave me the absolute perfect place to wrap it up, Aric. That was such a treat. I'm so glad we finally got a chance to connect, and I'm interested in keeping an eye on what you're working on down the road, particularly this study that you've just been talking about, because, sort of as the follow-up episode to the one we did a couple weeks back with Dana Johnson, talking about the disparities in sleep across racial groups. It's interesting that's a thread that seems to be going across science in a variety of different ways right now. So I'm excited to see the results of that when it comes along. But in the meantime, thanks for having time for this today. I appreciate you making room for us.
No, yeah, absolutely. Sleep is I really see sleep as like a social justice issue. And, I think that's a really important perspective for people to take across science, but sleep included, because though it's something that everyone needs, it's not something everyone gets equally. And a lot of that has to do with kind of upstream factors that have there's a lot of room for improvement. So, but yeah, it was great to chat with you, and anytime.
That's Dr. Aric Prather from UCSF. Links to the specific studies we talked about and his Wired video as well, waiting for you on our website at thesnoozebutton.com. Now we move to the second part of this week's episode. My friend Dr. Michael Grandner is back from the University of Arizona. All right, so in honor of your 74th appearance on the show, I think, or something like that.
Something
Michael,
like
how
that.
Did you sleep last night?
I slept great last night, actually.
Ooh, okay, good. Does this mean the forest fires are away from your door now? Is that how that works?
Yeah, I mean, so it's been a couple weeks now. Now they're up to over 100,000 acres burned, and but they're saying it's mostly contained. And honestly, after the first week or so, which was kind of scary, the winds changed, and most of the areas that were at risk were in the other direction, which is a bit more remote, which is good. And I think so far they've been able to save. I mean, I'm not seeing on the news lots of reports of lost structures. They really went after it aggressively to protect homes, and even though there were a number of evacuations needed, the firefighters did a fantastic job, and even as the fire grew, they kept it from getting to a place where there were a lot of people. So that was good. No, it's really good. And the news has been good for the past few days about it, and it's still a little smoky in the morning, but that's about it.
So, and this is interesting too, because I mean, there are a whole ton of people, whether it's a scenario similar to what you're going through, where there's natural disasters happening, or the other disasters that are happening all over the world, like COVID-19.
Because there's nothing going on right now.
Yeah, exactly. There's nothing. The world's a very calm place right now. Dumb question, and this may be too much of a layperson question, although I suspect that there are a few things that fall into that category. Where's the line between I'm having a rough couple of nights falling asleep versus I have insomnia? Where does that line come in?
So that is actually a fantastic question. There's an easy answer and a hard answer. So the easy answer is something called the rule of threes. So there's three things to think about. Either, so first of all, if it's happening 3 nights a week or more, that's where you start worrying. If it's happening 1 or 2 nights a week, it's not in the category usually of something to worry about unless it's really impacting you, and then we can deal with that. So 3 nights a week. If it takes you 30 minutes to fall asleep during in the beginning of the night, or you're up for at least 30 minutes during the night, so if it's taking you at least 30 minutes to fall asleep trying, I mean, if you're just sitting there reading, that doesn't count. Or if you're awake during the middle of the night for at least 30 minutes where you're trying to sleep and you can't sleep, the 3 nights a week. If you've crossed that line, I would pretty confidently say that what you've got is an insomnia versus just some difficulty sleeping. Now, there's 2 places where this gets complicated. For a diagnosis of an insomnia disorder, technically there's another 3 involved, and that's 3 months. So once it's been going on for 3 months, then you can, usually would get a diagnosis of insomnia. But what if it hasn't been 3 months? So we would call that acute insomnia or new onset insomnia or short-term insomnia, but that's just as real as anything else. Most of those cases might resolve on their own, but some of them don't, and they become chronic. So the first wrinkle is, how long has it been? If you're starting to experience problems, and it's been 30 minutes a night, at least 3 nights a week, you might have an acute insomnia, even if it's just new, and now's a good time to intervene on it. So that's one wrinkle. Another place where this becomes complicated is, who decides on 30? So all right, so this is where the academics start splitting hairs of, well, okay, so if 30 minutes is bad, is 29 minutes good? How about 29 minutes and 59 seconds? Is that good?
It becomes like the best before date on the milk.
Right. And so
if I guzzle this down before 11:59, I'm fine. At midnight, it turns into sour cream.
Exactly. See, so real people understand that 30, it's nature doesn't work that way. Like, oh my gosh, you crossed 30, the world is now different. No, it's not a threshold. It's a rough guide. So if it's taking you 25, 27 minutes and it's bothersome, good enough. If it's taking you 32 minutes and you're fine with it and it doesn't bother you, maybe don't worry about it. But that's usually a rule of thumb. So 30 minutes in the beginning or middle of the night, at least 3 nights a week, and to make it chronic, 3 months. So that's sort of the rule of thumb we use in clinic.
Okay, so enough of what's been on my mind. I know you are a person that watches emerging sleep science like a hawk. So talk to me about the stuff that's kind of crossed the radar for you since the last time we got together. Yeah,
so there's 2 things in particular that have been around for the last week or so that have really been on my mind. And there's 2 other things that I'll talk about too. But first the 2 studies. First is a study. I forget where it's from, but it was reported where it wasn't sleep scientists involved. It was actually computer scientists, and these computer scientists were developing artificial intelligence networks and using complex machine learning algorithms, where they're trying to teach computers how to learn complex relationships among information. And so for machine learning sounds very fancy, but basically what it means is, how do you teach a system to learn new information? And a lot of times those rules could be relatively simple. Like, if you see this, do this. When comparing 2 different things, go with the bigger one. Like, there's rules you can put into a system that you can help it learn, right? And so machine learning itself and AI actually can sometimes be quite simple, but sometimes it can be insanely complex, where the rules themselves are not set in stone, and the rules can end up writing themselves by figuring out what they are. So you have these really complex systems. And what this study showed was that, or what these researchers found was that even in this computer system, when they got to a level of complexity in the AI where it had to learn very complex relationships by sets of rules, what they found was, if they let the machine just run, it would eventually start becoming inefficient. But if they introduced sleep to the system, where they had it stop for a period of time and then start again, it actually became way more efficient. and had less error in the system. And what that shows that, we say like machines never need sleep. Robots never need to sleep. Well, it turns out it might be the case that as we develop more complicated machines, they might need sleep too. And it really gets to the point that we are learning as humans something that evolution and biology figured out a very, very long time ago, that once you get to a certain level of complexity, you can't be maximally efficient constantly all the time. That the idea of the rest activity rhythm might be an inherent requirement of complex systems. Like maybe complex systems, once they reach a certain point, they can't just keep going. They need rest for some reason.
This reminds me of old Windows computers that it used to be, and I don't remember if Windows 10 does this or not, because I have a different schedule than most people, so Windows probably looks at me and goes, what the hell is this guy doing? But old Windows computers used to, at 3 o'clock in the morning, 7 days a week, defragment the hard drive, which was basically a process where it grabbed information from all the various places it was stored and tried to rearrange the storage so that it was more efficiently accessible the next day, which the more I think about the way you're describing it and the more defragging your hard drive used to work, it sounds like the Windows version of the glymphatic system.
Yeah, I mean, it's interesting where I don't know enough about the computer science to know how apt the analogy is, but it sounds about right. I mean, at least at the core, that when you have a complex system and it's engaging with other systems, whether it's your computer engaging with you or the internet or programs or whatever, and while these things are happening, there might be a level of I don't know, whether it's error, whether it's waste, whether it's inefficiency that gets systematically introduced into the system, where you systematically need to purge that in some way or refresh that in some way. Maybe there is no perfect way to never need sleep, even for your computer.
That's amazing. Okay. I love this stuff. Okay. All right. What else you got?
Okay. So that was
my mind already. So let's see what the next thing is.
So that was the one thing I've been noodling on. The other one is a study that came out of Singapore. So there's a research group out in Singapore at Duke NUS, at the university there, led by a researcher named Mike Chi. And they do really, really cool stuff. They're often at the forefront and thinking creatively about sleep neuroscience. And one of the things that they were able to do actually was to get a bunch of Fitbit data from people in Singapore and follow them through the pandemic so far in Singapore itself, where they had, it's like probably, I think it's several thousand people that they looked at, where they essentially, it was like 2,000 people, if I remember correctly, and they tracked their sleep over the course of the pandemic with social distancing and lockdown, and then also they compared that data to like 2019 data to see, is this trajectory different? Maybe sleep is changing, but maybe sleep changes every year. So they were able to do that. And there's a few really cool things that they found. First of all, that like this physical activity restriction seemed to dramatically reduce how active people were. But what was interesting to me especially was in the sleep. There's something really interesting that happened where there's lots of talk about people sleeping less, maybe, and having more sleep problems. But one of the things that they found was that on average, sleep was increasing. And sleep was increasing over time in such a way that sleep variability was also decreasing. So what was happening is people were sleeping more and more on average, but when you looked at when you plotted how much people were sleeping, and you looked at the spread of those numbers, the spread was decreasing. And, but you think like, well, some people are, they're a little more irregular. But it turns out that signal came from something very important that we're seeing. It's that weekends are now weekdays and weekdays are now weekends, and actually that people might still be pretty variable about when they're going to bed, and some of them might be staying up later. So that was another thing, that bedtime has been drifting later and later for a lot of people. They found that wake time similarly was drifting a little bit later. That time in bed is drifting up a little bit, and total sleep time was sort of drifting up a little bit. But the key thing that jumped out was, the difference between weekdays and weekends has been getting smaller and smaller. And that I thought was really interesting, that, we have this natural experiment where out in the world, people were stuck inside. They couldn't really go anywhere, especially in Singapore, that was very locked down. And what they showed was when people were stuck inside, they moved a whole lot less. But they ended up sleeping a little bit more. It didn't say anything about sleep quality, because that can't really measure that. But, that as our schedules sort of, changed, that when people were left to their own devices, they actually still slept in a little bit on weekends, but not nearly as much as they used to. And if anything, they were just sleeping in a little bit more during the week, even if they were staying up a little bit late. So I thought that was really interesting, as just sort of a, peeking under the covers, so to speak, of like what's going on out there in the world.
Well, and peeking under the covers with COVID-19 has kind of been in your wheelhouse in other ways too, right? Because of this task force on COVID-19, and I think part of the title was Managing Sleep in a Pandemic.
Yeah, so the Society of Behavioral Sleep Medicine is an organization. They're like the main scientific, clinical organization of behavioral sleep medicine. So that's the field of sleep where people treat sleep disorders, but not necessarily with medication. So it's a lot of psychologists, nurses, social workers, and physicians are in there too, but the ones who also, in addition to medications, also do like behavioral treatments and things. So Society of Behavioral Sleep Medicine. And people should know that like the main sort of jewel in the crown of behavioral sleep medicine is cognitive behavior therapy for insomnia, which is, it's the recommended first-line treatment for insomnia. And since insomnia is so common, there's a lot of insomnia people in this society. So anyway, so the SBSM put together a COVID task force. They got a bunch of us together who were sort of seen as, maybe leading voices in this area to say, all right, what should people be doing about sleep right now? And it's written for... It's mostly written for people who might be seeing patients, because that's who's writing it. It's a bunch of mostly psychologists writing it who are sleep therapists, for other people who might be seeing sleep patients, but also for people out there who are dealing with sleep problems. How do you wrap your head around them? So this article is free. If it's published in the journal Behavioral Sleep Medicine, and if you Google it and find it, and you go there to the link, you'll see this paper is super short. It's like 2 pages long. It's like, well, yeah, we needed that to get it in the journal at the last minute. But if you look at the supplementary materials, there's actually the full paper is in there with examples and like, okay, man, here's an example of a patient and they have kids and this is what they're struggling with. What should they do? So there's vignettes in there. There's also handouts for parents. There's like handouts for doctors who are and nurses who are on the front lines. Like, what should they do? So there's all kinds of resources on there, and it's totally free. All you just, and I can, I'm sure you could post a link and I can send it to you.
Yeah, I've got the link right up in front of me, as a matter of fact, and I'll make sure it's on our website at thesnoozebutton.com, because it's fascinating. The handouts are amazing. So you do want to take a look at this thing, because it's a great resource.
So two other things. So I was talking about how there were these two studies that have been on my mind. There's the real world Singapore study, and then there's also this opposite of the real world in a computer brain study that I've been thinking about. But a couple of other things. One is this SBSM thing. I'm glad you brought that up, because people hopefully could benefit from this. I should also, even though I was on it, I didn't lead it. The leader was a guy named Chuck Crew. He is a psychologist who does sleep. He led this charge. There were others involved. You'll be able to see all the other authors on here. Like, we all contributed. But there's also something else that happened in the last week or so that was really, really on the minds of a lot of people in sleep, and that was the death of Bill DeMint. So for your listeners who don't know, Bill Dement often has the title of the father of sleep medicine. And he definitely deserves that title. He was there when they discovered REM sleep in 1950s, and when he was a student in Nathaniel Kleitman's lab, Kleitman, I guess in that case being the grandfather of sleep medicine, setting up the first sleep clinic, creating the first sleep scientific society, the first sleep conferences. Like he drove the field, and he was actually, I was only able to meet him a couple times. But he was an extremely dynamic person. We were very lucky as a field to have him be the person leading the charge. The idea of sleep as a public health issue was something that he was doing decades before anyone else sort of took that mantle. And so, like, it was a real, every important sleep award is the Bill Dement Award. At Brown they have Dement Fellowships, and the Sleep Research Society has their Dement Award, and the American Academy has their Dement Award. Like, he was a major figure in the field. He really pulled the field out and put it out into the world. And he was quite old, and his health hadn't been great for a few years, but it was definitely a big loss for the field and the sleep field. Everyone in the sleep field felt it when it happened. And I think, if your listeners are interested in sleep, he wrote a bunch of books, but the one that I like the most, it's called The Promise of Sleep. And it really tells the story of where the sleep field came from and what it was like back in the day. And then we discovered this, and then we had this crazy idea, and that totally didn't work. But what we found was this, and this is why it's interesting. And he tells this great story. So I definitely recommend that book for people.
I'm going to throw one thing at you that popped up for me as well, and it was a study, and I may be throwing you something that you haven't even seen yet, which would surprise me, but still. I was looking at the headline on the story is one-time treatment generates new neurons and eliminates Parkinson's disease in mice. Now, and I made sure that I mentioned the in mice part because I know that's a favorite of yours. But this is a study out of UC San Diego School of Medicine that was studying a protein called PTB. And what they found was by manipulating this protein, they could force the mice brains to generate new neurons, and it would basically, after a one-time treatment, knock out Parkinson's disease. The reason that I'm bringing up Parkinson's on a sleep podcast is because of this stuff right here, which your friend and mine, Dr. Mark Boulis at Sunnybrook Hospital in Toronto, put me on medication for Parkinson's to treat my restless legs syndrome. Okay. Now, this might be a question that is better aimed at Richard Allen from Johns Hopkins.
Yes. I already know the answer to this question is yes, but I'll do my best.
Okay, good. Because my question becomes, if they can manipulate this protein in mice and knock out Parkinson's, could that also have an impact on restless leg?
But potentially. So I'm actually looking at the paper right now. I hadn't read it because it was a Parkinson's basic science paper, and I don't read all of those. But so I'm looking at it right now, and so an interesting thing about Parkinson's disease that a lot of people may not know is actually what Parkinson's disease is that sort of deep in the brain there's an area called the substantia nigra, which as most people could kind of guess, I love this idea of scientific sounding words that are actually kind of banal and silly, but the substantia nigra, like if you think about it, substantia nigra, it's black stuff. It's the black stuff in the brain, and the reason it got that name is because usually we call the brain gray stuff, right? It's gray matter, and that's the cell bodies are gray colored, but in the substantia nigra they're kind of blackish. And in the substantia nigra, there are cells that produce dopamine. And most people have heard of dopamine. They usually think about it in terms of reward systems or energy level and stuff. But dopamine also plays really critical roles in muscle movements and other things. Dopamine is a neurotransmitter. Neurotransmitters, it's like salt. You use salt on lots of different things. It does lots of different things in different foods. It's not just for making spaghetti sauce. Like, it's also for making tacos. Like, you use it everywhere. So dopamine is like that, where it has lots of different functions. One of them is controlling muscle movement. So what Parkinson's disease is, it's basically the cells in the substantia nigra start dying. And they eventually stop producing dopamine. And it used to be that the main treatment for Parkinson's was just supplementing dopamine. You can't give people dopamine; it won't cross it to the brain. You have to give them a drug that will create more dopamine in the brain, but then that causes side effects. So the newer drugs sort of boost dopamine levels in general, especially in terms of muscle movement. So that's essentially what Parkinson's disease is the substantia nigra starts dying for whatever reason. Sometimes it could be autoimmune, sometimes it's just aging. There's all kinds of, sometimes it's genetic. There's all kinds of reasons why. Now, the reason why restless legs is treated with low-dose Parkinson's medication is because it looks like, at least for a bunch of people with restless legs, again, Dr. Allen would know way better than me. He's like the world's leading expert in this, and I just dabble because it's not my main area. But the idea is that some of these pathways are overlapping, and by treating it, and you're talking about like a fraction of a dose of what you would give a Parkinson's patient, but it seems to work along that same neuromuscular sort of pathway. But that's also why the main side effects are like the side effects of maybe having too much dopamine. So getting back to your question, if they could, so what I'm looking at here in the paper, again, I'm just browsing it, like live while you just brought it up. And there's lots of acronyms that I don't even know how to pronounce on this one, but it looks like the story is, it's using cells called astrocytes, which are not neurons. So there's other cells in the brain called astrocytes that have other functions in the brain that sort of people, like you could just think of them as sort of like helper cells in the brain that do other stuff that sort of assist the neuron. But what it's doing is it seems to be converting some of these, because you don't grow new neurons, but you could potentially create new astrocytes and like you could, there's a whole field of like astrocyte research. So, and also astrocyte. Cyte, CYT, like cell, like cyto, whatever. Astro, it looks like it's like star-shaped. So astrocytes. And so it looks like what they're doing is they can convert these astrocytes into a functional neuron and have them change shape and change function. Again, not reading this in super amount of detail, but if the problem is that the cells are dying, but there are other cells in the area that you can now deputize and turn them into a replacement for some of the cells that died, maybe what you could do is you could potentially reverse this process. If whatever caused the cell to die in the first place isn't effective anymore, or whatever, blah, 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 blah. But as a proof of concept, this is super cool. Also, from a sleep perspective, I wonder, you mentioned the glymphatic system and this idea that the brain exists also in a 24-hour day, that there are things that happen in terms of the brain. And there's actually a whole world of astrocyte sleep research. I can give you some names of colleagues who do this sort of work, but we're looking at the function of astrocytes in sleep is actually also really interesting in terms of lots of different types of maintenance functions. So I wonder, if I were talking to these people and wanted to do a human study on this in particular, I'd be interested to see if this effect happens during sleep, and if you could optimize it in that way.
So much interesting. See, now I have to put a call into Richard Allen. So I have more investigating to do. But I saw it and I thought, next time I talk to Michael, I have to ask him about this. Because there are so many of these things where you're researching X and it turns out you found a cure for Y, and those things sometimes happen by accident. And I wondered when I saw it and I realized that, I'm on a super low dose Parkinson's medication for my RLS. I thought, okay, well, wait a minute, let's investigate this further. So Yeah, thank you for making me feel like I haven't completely gone off the deep end, and now I got to go ask other people. I love this. Listen, the reason that Michael is here is because he doesn't have time to do his own podcast, and so he comes and hangs out with me now every week, and I'm super grateful for the time, and there's always so much stuff to learn every time I chat with you. I'm so grateful for you having turned me on to Dr. Dana Johnson.
Isn't she awesome? She's fantastic.
She's amazing, but all these people seem to have one connection in common, and that's you. And so I'm super grateful you can make time, and thanks for doing this, Michael.
Thank you very much. I'll talk to you next time.
There you go, Dr. Michael Grandner. Link on our website at thesnoozebutton.com for the information that I was talking about with Michael, plus all the stuff from our chat with Aric as well, and his Wired video that was a big hit for people as well. Tons of information there for you on our website. All the back episodes are there. Subscribe buttons for both the regular length edition of the show and the Snooze Button Express, which is a 9-minute version of each and every episode. We're catching up on the production of those episodes. We're still way behind, but we're adding new episodes as quickly as we can to hopefully get caught up to where we are in the present time. Also, a contest page there, a way to leave a question for our panel of sleep experts. You can rate and review the show and even support with a donation to help keep it commercial free too. It's all at thesnoozebutton.com. Until we get together next week, my name's Neil Headley. Hey, get some sleep, would you?